A blessed day to each and every one of us. Welcome to PAES webinar entitled Drones Are Coming. Are you ready? To start with our program, let us request a moment of silence for us to listen to the invocation and to join in the singing of the national anthem.
Kindly hold as I share my screen for our invocation and national anthem.
Let me be the change I want to see, to do with strength and wisdom all that needs to be done, and become the hope that I can be. Set me free from my fears and hesitation. Grant me courage and fill me with spirit to face the challenge and start the change I long to see. Today I start the change I want to see. Even if I'm not the light, I can be the spark in faith, service, and communion. Let us start the change we want to see, the change that begins in me. Today I start the change I want to see.
Even if I'm not the light,
I can be the spark. Service and communion. Let us start the change we want to see, the change that begins in me.
Jesus in us.
Jesus in us.
So kindly wait for the Philippine national anthem.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, ewas ng sinakalan. Alam ng puso, sa dikit mo'y buhay. Lupang hinirang, tuyag ka ng magiting. Sa mandulupin, di ka pasisigil. Sa nagagang tutok, simoy at sa langit mong bangaw ay hinatang tulakaw
Thank you very much, Linky. And now to formally start our program, but before that, let me introduce myself. I am Dr. Filipina de Guzman, the PAES Secretary from Holy Angel University. And with me is Dr. Kathleen Aviso, the Director for NCR from De La Salle University. So to start with our program, let us call on our PAES President, Engineer Evelyn Q. Ragindin, for her opening remarks. Dinle?
Hello, good morning. Thank you, Dean Lee. Good morning, everyone. Good morning, our partners in engineering education. On behalf of the Board of Directors of the Philippine Association of Engineering Schools, it is a pleasure and an honor to welcome all of you to this webinar. This is the third webinar of PAES as our commitment to excellence and partnership through our network. We are very fortunate to share with you an offshoot of an innovation that started out in one of our member institutions, De La Salle University. XLIPOD is a DOST-supported spin-off company. This has been a long overdue commitment and partnership with XLIPOD, and fortunately, after a year, we were able to share this with you, with our partners. Much like every other industry, the engineering landscape is evolving at a rapid rate. So the demand for engineers with an innovative and entrepreneurial mindset has never been greater. Innovation and entrepreneurship are key drivers in today's engineering world, and the push for sustainable products and services and technologies is needed now more than ever. So innovation is an excellent influence on the growth and survival of today's engineering world. For us in the academe, schools should be the first institution to foster innovation by adapting technology which students can use to develop new solutions to existing problems. But beyond having the adequate facilities and equipment, we must be able to act as mentors to provide aspiring technopreneurship with quality education. So this morning, our president of XLIPOD would share with us the product of their innovation, and hopefully you would listen and experience to the experiences and insights of our guest speaker as one transition from an engineer to an technopreneur, the output of the creative mind, and how this is translated into a commercial product and services. Again, on behalf of PAES Board, magandang umaga po, and thank you for spending your morning with us. Good morning.
Morning, Dindin, and thank you very much for directing us to the very purpose of this webinar. So I have the honor, and it's my pleasure to introduce our guest speaker. Dr. Alvin Chua is a full professor of the Mechanical Engineering Department of De La Salle University, Philippines. He earned his BSME, MSME, and PhD in ME Mechanical Engineering at De La Salle University, Manila. As a scholar under the Department of Science and Technology, Engineering and Science Education Project, or DOST-ESEP. He conducted his dissertation research at the University of New South Wales, Australia. He recently received an award as Fellow in the 2020 Leaders of Innovation Fellowship. This was sponsored by the Royal Academy of Engineering in UK, Asian Institute of Management, and the Department of Science and Technology. He has published several papers in international journals and conferences. His research interests are on mechatronics, drones, robotics, optimal estimation, and controls. Dr. Chua is also a co-founder and president of XLIPAD Solutions Incorporated, a tech company that manufactures and pioneers the local development of cost-effective educational drones in the country. So without further ado, we now welcome our guest speaker, Dr. Alvin Chua. A virtual round of applause.
Good morning to all. Thank you very much, Dean Filipina, for that very kind introduction. And of course, I would like to acknowledge Dean Evelyn, and of course, President of PAES, and of course, our beloved Dean of the College of Engineering in De La Salle University, Dean Kay. Good morning to everyone, and it's nice to be here in PAES, and thank you very much for the honor of being able to present to such incredible participants, all coming from different members of PAES. I hope that you learn something from this talk. I will try to make it as quick as possible and as clear as possible for us to benefit from this talk. Let me just share my screen. So let me just make sure that I share the sound. Yep. For a while. Right. So my title for today is all about drones are coming. Are you ready? And of course, this is a partnership with PAES and XLIPAD, and we are very honored, to be able to be given a chance to be able to share what drones is all about, and also share some of our products and services that you may be of interest, especially to universities and colleges all over the country. So I am Alvin Chua. I am the president and co-founder of XLIPAD Solutions, Inc. As mentioned earlier by Dean Evelyn, we are a spin-off company, coming from a DOST project, So, and we are currently doing our first year, Our first year of spin-off, official spin-off. I'm also currently a full professor at the Mechanical Engineering Department. So what is XLIPAD first? Let me just give you some insights on who we are. XLIPAD, LIPAD is an acronym for Light Intelligent Platform for Autonomous Drones. So we are really into autonomous systems, and one of our products is, of course, drones. What is our mission? We are a God-led company that aims to accelerate innovation and learning through the use of custom-engineered educational and commercial autonomous systems. So that is our mission. So as a team, we are of course professors, coming from the university, but we've been doing a lot of research, specifically about drones, about robotics for so many number of years, And we feel that it is important for us to be able to go to market, make use of our research, be able to give what we have learned and translate it to a certain commercial product. And that is what we are doing right now. And I think that is also what is happening all around the world right now, that we do not get stuck with our publications in the library or in an e-library. We would like to have our research, our publications to be part of society, to give back to society. And that is really the mission of XLIPAD, to give back what we've learned, from our DOST project, from all the researches that we've done, and to give it to the market and to help the future generations. So just a quick history about XLIPAD. So it started as a DLSU research team, as in most of us, we have a research team at our own universities, and we create now our products or our researches, no, that we feel that will help the market. No? And sometimes we as researchers, we sometimes we do not go out in the market, no? And we do not really see what is really needed in the market. And that is, I think, one of the shifts that we need to do as researchers. So that is the risk, or that is the step that we took. And of course, through the help of DOST funding, through 2 grants, no, coming from DOST, no, we were able to create our drone research, no, in particular. Back then, that was around 2016. No, I still remember that we had this road mapping, no, coming from DOST, no, and particularly we did what we were part of the UAV road mapping, or the unmanned air vehicle road mapping, no, and with that, back in 2016, 2017, or even before that, it was said that there were a lot of interest about drones, no, if there were a lot of projects that were being proposed to DOST, and most of them would come with a drone. So with that, DOST that time introduced drones and the possibility of creating our own drones here in the Philippines. And that gave birth to XLIPAD. No? And with that, we are now still continuing our development, which is of course part of research. And hopefully we are able now to develop more technologies that will be helpful for the market. So we are tackling specific, of course, the sustainable development goals are very important for a sustainable life in the future. In particular, XLIPAD, we are actually concentrating on quality education as our SDG. No? And we know that the Philippines still ranks low, no, in terms of reading, math, and science, no, in our previous evaluations of our students, and that is really unfortunate. We know that we have the very capable faculty, very capable schools all over the country, you know, as represented here in PAES. And we believe that we need to level up. No, we need to also give to the students, and we know that we can give a lot to the students, no, to improve quality of education, not only in the collegiate level, but also in the secondary, even in the high school or senior high school level. So that is unfortunately what is happening. But we also know that robotics is beneficial to education, and we know that it is beneficial because it is fun, it is exciting, it is high tech. No, it's all about, it's like a cell phone. No, it's like everybody would like to get one, no? And everybody would like to have one and to understand what is a drone. No, and I believe that a drone will be like the next cell phone. No, it will evolve that everyone would need a drone in the future. No, so it is it will be very much needed in our lives. No, so robotics has been used in education throughout the different levels, no, from your primary to your secondary to even the tertiary level, and we know that it works already, no, and it really helps to improve the quality of education by exciting the minds of students, no, giving them possibilities, giving them a platform for innovation, no, which is really key right now, no, not just teaching students knowledge that we know right now, but teaching them to think on their own, to produce their own ideas in the future. But the problem is that industrial grade educational robots are too expensive, no, and they would go to the millions, no, even, no, and but there are existing budget-friendly educational robots, but have limited learning capabilities and does not really give as an innovation platform, especially in developing Industry 4.0 skills, no, which are really higher level skills. No, of course we know all the buzzwords like AI, no, big data, machine learning. No? So all of these terminologies all form part of Industry 4.0. So with that problem, we have now developed a solution as part of doing research. No? And this particular solution encompasses most of our learnings, no, during our years of research. And it's called our DREAM systems, or Drone Reimagined for Educational Applications and Modifications. So it is a complete system that is flexible in learning drone education. And it can be integrated into the school's curriculum in different ways. So later on, I'll give some ideas on how some of our clients, or how probably you could also apply it to your respective universities. And they are used to explore areas of technologies under UAV. So we know that UAV is a multidisciplinary type of product, when we talk about a UAV or unmanned aerial vehicle, or when we talk about a drone. So here we have, of course, a quadcopter drone, which is like a de facto standard when you talk about drones right now, because of its ability to have a VTOL, or a vertical takeoff and landing. Of course, there are different types of drone. Later, I will expound it more. But using this system, we are able now, using this DREAM system, we are able now to integrate most of our solutions, most of our researches into the full system, into the full package. So the package actually comes with hardware, which you saw earlier, which is a hardware that can be modified, that you can add into, or you can even add a companion computer, in order now to expand your computing capability. Unlike probably the regular drones that you can buy in SM, or you go to a mall. Usually the drones will be closed in nature, meaning it can do a particular task. Mostly, of course, it's about photography, or doing selfies. Now, I'm sure most of you have encountered a drone already, and it's one of its main function. But unfortunately, there's no drone in the market that you can modify, that you can look at the program, that you could add sensors to, that you can modify even the payload, and do certain tasks, that do different applications. So this is our DREAM system. Our hardware is a innovation platform. Not only is it good for teaching, but it is also good for research or innovation. So there are a lot of researches that you can do depending on your application, depending on what particular technology, that you would like to, what area, of course, in mechanical engineering, you can even study kinematics, dynamics, aerodynamics of drones. And of course, for electronics, you can already study the electronics, the sensors, the softwares, the image processing. So there are a lot. Even for civil engineering, you can do mapping, you can do surveillance, you can do feature extractions. So almost different applications, almost different. All the different sectors can benefit from the use of a drone. So our drone package comes with not only hardware, but it also comes with a software, modules, and also training. So we made it as a complete package so that it will be whoever, or universities or schools, can have this jump start on this technology. What we learned for years in doing our research project in the OST, you will learn it in a short time. And it will jumpstart your development in drone technology, which is really happening already abroad. Later on, I will let you see some of the other drone hardwares that are available abroad. And if you're going to use this jumpstart, no, this hardware, the software, so we made it as a system so that any university can easily learn the hardware, the software, which is in fact an industry grade software that is being used, no, commercially right now, no? And the modules are specialized, no, in order now to integrate the learnings of hardware and software into the curriculum, no, of the university, no. And there are different modes, no, that you could use in order now to learn drones, no. First one is through online workshops, no. So it could be done 1 day, 2 days, no. It could be similar to this. It could be webinars, no, especially since we're still transitioning into the face-to-face, no. So online workshops and online implementations are still very important. You could also apply it to elective classes, no, to your university to gain interest coming from different sectors, whether it be faculty or students, no, that are interested in drone technology, or it could be also incorporated in some of the courses, no. So if you're in senior high school, or in some schools that are offering senior high school, maybe applied to technology empowerment, or maybe applied to certain elective classes in the university level, and also to clubs, no? So those are some of the creative ways on which you could use this package in order now to develop your courses, no? So it is flexible and can be applied to different modalities. So I will explain this more in the second part of my talk. So what is really the aim of XLIPAD is for us to create a collaborative experience, no, a collaborative implementation of understanding drones, no. Drone is not just a four-motor flying robot, no. It is actually a complex system that has different Industry 4.0 skills development, like Internet of Things, no, of course, robotics, artificial intelligence, even sensor fusion, no. So of course, I'm not going to go into some of the details of the algorithm, but there are a lot of algorithms that you can implement inside the drone, no? And in fact, in order for you to fly the drone, no, you should be able to understand some of these concepts, no, like control systems concept, no. For some of you may be familiar with the proportional integral derivative controllers, no, which is like standard, no, whether it be industrial controllers or robotics controllers. All of these form part of the ecosystem of a drone. That's why DOST found it also very important to integrate it within our, because we would like to be one of the best in drones in the future. And I think when we were given the opportunity to go around the world, no, to visit different universities, and I would say that when you are able to understand, or with this, using this dream system, we are now at par with some of the best universities teaching drones in their university. So, of course, we are looking at universities and senior high schools for this dream system, more than 2,000 and 4,000 for senior high schools. And that is our initial targets, although there are a lot of commercial organizations that are showing interest, no, in this system. Then we now have our we have also competitors, no, for our XLIPAD. So it's not really new. The concept is not really new, no. It's been applied in the US, no, for quite some time right now, no. But I would say that we are very competitive to them, and at the same time we customize the modules, no, which are really there to help you understand the whole system, how to build, no, how to create, no, and even how to install the softwares and how to definitely fly it, no, or understand how to fly the drone, no. then you have local support, availability of drones, then we can now implement other sensors and other activities. So currently we are going to different markets and deploying this system. And we believe that, in fact, when we offered this, I think 4 years ago, when we were still a DOST project, there were already, when we advertised that we are able to deploy drones to the universities, there were around, or to help us evaluate the drones, there were almost 200 universities that responded interest in the drone system, and with just probably around 2 days of advertisement through DOST and through other media platforms. It really shows a lot of interest for drones in the universities. And we've deployed really to 20 universities right now. Later on, you will see some of their testimonies on how they felt, both face-to-face and online, because we know we have certain limitations right now, in terms of modalities. But of course, we hope to be able to do hands-on. We as engineers, we know the importance of hands-on in terms of the development of the students, and that's really our goal. But the beauty of this system is that you could either implement it in face-to-face or, of course, in online mode, with certain limitations, but still getting the concepts needed, and doing some, and as I mentioned earlier, some of the institutions, government institutions, are also very interested in this system. So here is our team of XLIPAD coming from, of course, from De La Salle University, from Electronics and Communications Department of Electronics and Communications Engineering Department, from the Department of Industrial and Systems Engineering, and some other staff, that are into part of our team. So let us revolutionize and innovate the global educational system, and to God be the glory always, in doing this project and this spin-off company. So you may email us for any concerns, or any information that you would like to have more, or you can visit our website at xlipad.com, for more information. So let me now segue and give us more information on what are the different drone applications. What are really drones? Now that you know who we are, what are now the different applications of drones that might be of interest to you? And probably give you an idea, probably give you also some bit of insights on how broad, or how important drone technology is ongoing right now. In fact, it is projected to be $100 billion business in 2025. So we would like to be in that progression, and I think the Philippines can make a mark with this. And of course, we need everyone. It's not just XLIPAD. That cannot happen. XLIPAD, a drone is like a car. It's a smaller scale. There are different types of different components, different types of a lot of things into it. Of course, the electronics, the hardware. Creating all of them would need a mass of students, of faculty, of researchers, of universities who are really into drones. Let me just give you a glimpse of the importance of drones through some of its applications. So what is a drone? When we talk about a drone, we can say that it is an unmanned ship guided by a remote control or through a computer. So it could be manually activated or manually controlled, or it could be automatic, using an onboard computer. And so meaning it is can be manually or automatically controlled, and it is being used right now, all over the world. There are different types of drones, and of course, one of the main capability is autonomous flights. No? And there are different types. So the one that you're seeing here, the one that I always keep on flashing, is called a multi-rotor. No? It's like a standard drone, no, with four modes. It's called a quadcopter. No? Are there other types? There are a lot. No, there are tricopters, there are octocopters, there are hexacopters, no, multicopters. Some even creates a unicopter system, no, which is similar to the helicopter, but also a bit different, no, especially in terms of control technology. Another type of drone is, of course, a fixed wing drone. No, it's like our regular aircraft, no, that we are used to, no, bringing people from one point to the other. No, so it's a fixed wing drone, and that's of course shown in different movies already, no, especially in war movies. No? So those are the different types of drones, no, either fixed wing and multicopter drones. When we talk about drones, there are different applications that are being done already, no? And so far, according to sector, still the military, no, plays a key role in drone technology, no? So the use of these types of military drones, of course, you may know, has a war connotation, no? And they've been used in different wars already, no? Especially by the US. No? But other than that one, a good percentage, no, around 30%, is already going into consumer. No? When talk about consumer, more of photography, more of mga implementations, no, that are for fun, no, for consumer implementations. Majority is photography. And for commercial, you're talking about still using photography, but using it for mapping, surveying, even for delivery. No, there are exciting applications right now for delivery. No, I just recently saw one with Walmart. No, I'm sure you're familiar with Amazon. No, delivering using drones. No, but there are a lot of big companies right now that are also doing drone deliveries already. No, one is Walmart. No, so. And then it's not far that we will be having these implementations already. But of course, it comes with government regulations also. No? So that's why safety is key in learning drones. And it is also part of our modules. So what are some of the top industries using drones right now? No? From bottom up, no? The green one is still photography, no? So whether it be movies or in newscasts, no, in television, whether it be in just taking your own selfie, no, drone photography is still one of the main applications. But other than that, real estate, no? In real estate, in surveying, no? In other utilities, no, being able now to reach high places, no, being able to survey high places, so that's part of drones, no? Construction, agriculture, no, which is gaining a lot of ground right now, no, especially in smart farming, no, in precision agriculture, no, so it's very important. And of course, education, no, drone education is now key. No, and it's already part of the applications of drones. No? And we see that as a key driver, not only to create drones in the future, but also to diversify ourselves to other Industry 4.0 skills. Once you know artificial intelligence, once you know machine learning, you can branch out to different sectors, and all the different sectors will be developed, no, through the knowledge of drone education. So I hope that I can encourage you to be part of that drive, no, of XCLIPAD. Then manufacturers, emergency use, especially for disaster situations, insurance, government, conservation. So these are just some of its industries, no, that are using this application. Just to give you an idea, of course, as I mentioned earlier, photography plays a key, and videography. Like if you're getting married, no, most probably you can already get a service from drones already, no, using photography and videography, and entertainment, no. So we now have drone racing. Maybe some of you are interested in that, and photography of live entertainment, especially in rallies, no, filmmaking, no. And of course, very popular right now are swarm drones, no, creating those beautiful patterns, no, lighting patterns, no. So that's one of the whether it be in the SEA Games, whether it be in the Olympics, no, it's been used already. And of course, delivery, no, it's one of the main. Not only delivery to the concern about rotorcrafts is that it has shorter flight endurance, no, compared to fixed wing drones, no. That's why delivery for long distances still uses fixed wing drones, no. And then for education, no, as I've said, no, when we went to the US, when we went to Taiwan, to Australia, to Japan, no, we already saw drone education, no, part of their curriculum, no, and we would love to see that here in the country, no, for us to move forward, no, not only in drone education or drone knowledge, but also to learn more Industry 4.0 skills, no, weather forecasting, disaster management, no. Drones has been used in order now to see whether a infrastructure has been damaged, where are some of the survivors, no. In fact, this is a competition in DARPA, no. So as in any technology, no, like the GPS, no, it usually comes from the military, no. First comes from the military, and DARPA is one of the main competitions that are used in order now to develop these types of technology. And to law enforcement, no. So in traffic situation, if there are accidents, no, drones are already being used, no. And usually in some countries, law enforcement goes with a drone, no. Hindi na lang mga ano nila, standard no, whether it be a gun or other things, no. A drone is already part of law enforcement. Mapping and surveying is one of its applications also, especially in construction. Then of course also agriculture, no, especially in terms of precision farming, no, or smart farming. So this is really part of the different applications, no. Drones are really there, no, when we talk about applications from medical to infrastructure to education. And of course the internet, no. Of course, one of our concerns is that the internet is cannot reach those far-flung areas, but now Google is now creating a solar-powered drone, no, unmanned aerial vehicle that can fly in a lower range, no, lower height, no, compared to the spacecraft, but at the same time have now the capability of producing internet, no, or passing internet to far-flung areas. Waste management and even advertising, no, advertising. So it really goes to different areas. And of course, right now in COVID situations, no, drones have been applied to different applications like temperature scanning, no, for at a distance, of course, no, surveillance, even broadcasting, and even delivery system, no, so that we are not infected. We will not be infected by when we give this. When we have these drones, no, and then we now have also disinfecting, no, as some of our LGUs was able to do or was able to use. In some of our LGUs are very familiar already with using of drones, no, in their respective localities. Let me just give you this, show you this short video about summarizing some of the future applications or current and also future applications.
Have drones taken over the world? Or at least, will they in the future? They're cheap enough for anyone to own, and are used everywhere, from tracking and filming athletes at the Olympics to changing modern day warfare. Within the last decade, soaring popularity and rising technological advancements have enabled new innovations to become viable, making science fiction a reality. So let's take a look into the future to see the purpose drones may serve.
Amazing!
To clarify, although the word drone has gained negative connotations due to their association with military uses, the majority of them are harmless. A drone is simply defined as an unmanned aircraft or ship that can navigate autonomously without human control or beyond line of sight. Here are a plethora of amazing future uses for you to think about. Number 10. Racing. Drones are certainly entertaining, and now that pilots can wear special point of view goggles to see where they're going, it's only a matter of time till they become as famous as F1 drivers. Flying a few feet above the ground whilst navigating obstacles at speed of around 60 miles per hour, it takes insane reaction times and hand-eye coordination to manoeuvre these tricky tracks. At the National Drone Racing Championships, enthusiasts are banking on big-time corporate sponsorships to go professional, and it's something that will most likely happen in the future. Elsewhere, drones battle it out through combat. Our obsession with fighting robots hasn't seemed to fizzle out at drones, as they've been put to battle in the appropriately named Game of Drones Combat League. At the moment, these types of contests are in their infancy, but it is likely that they'll be super popular in the near future, because let's be honest, we just watch the races to see crashes and destruction anyway. What will be particularly exciting to see though, is if developments in augmented reality will be integrated at these events. Maybe a racing event combining combat could result in a tournament similar to some kind of Star Wars chase. Number 9. Surveillance. Drones are likely to become increasingly involved in civilian surveillance, from border security to law enforcement, but most significantly, we've learnt from Call of Duty how important UAVs are in combat. Therefore, to meet growing military needs, drones will have to innovate. Currently, drones like the Watchkeeper and Reaper are utilised, but cooler drones like this Black Hornet Nano are used on the battlefield. Amazingly, it weighs about the same as 3 pieces of paper, despite carrying 3 cameras. It's an incredible piece of kit with a hefty price tag to match, but perhaps it isn't the definitive answer to modern day reconnaissance, as it's vulnerable to even weak gusts of wind. Along with a growing need to have eyes inside buildings or close on the ground, the future of surveillance may come from other micro air vehicles that take inspiration from nature. Bionic drone birds that can be hidden in sight and compensate for oncoming gusts by flapping their wings asymmetrically may be one solution. They would be able to enter locations which were previously inaccessible by traditional means, and multiple MAVs, each with small sensors, could perform swarm operations to work together to survey large areas. It's so mouth-watering for the military that DARPA is of course investing in its development. Yet, as we've seen, even civilian drone fighting suggests that we cannot resist weaponizing this sort of drone technology. Number 8. Weaponry. We all know that the military draws at the implications of this sort of technology, and although many people abroad and at home bitterly oppose this, there's no doubt that drones have already revolutionized warfare, so the military won't shy away anytime soon. So far, drones that were originally meant solely for surveillance, such as the Predator and its larger brother, the Reaper, have inevitably been equipped with missiles and used in covert operations throughout the Middle East to destroy potential threats. But with more remote pilots now being trained than fighter and bomber pilots combined, it's easy to see what's on the horizon. Sophisticated manned fighter planes will also be replaced by killer drones. In fact, the US has already successfully developed and tested the X-47B, and its larger brother, the X-47C, is still in development. Similarly, unmanned drones may change the naval battlefield. Russia even leaked plans to long-distance underwater drones equipped with missiles, possibly even nuclear ones. Or what about fitting those nano drones with precise targeting weaponry, such as incapacitating chemicals or explosives? Obviously, computers must go some way before these ideas become possible, which is why the Pentagon is currently funding groundbreaking research to develop tiny microchips with brain-like artificial intelligence, such as the Iris. All this seems to suggest that drones will be able to kill all by themselves, a prospect that leading thinkers including Elon Musk and Stephen Hawking consider frightening enough to call for a ban on them. Nevertheless, not all drones are being developed for war, even though they're extremely useful for it. Number 7. Humanitarian relief. Most drones are a cause for good. In fact, there's even a high-profile competition in the United Arab Emirates to prove it. It is dedicated to transforming the innovative technologies behind civilian drones into practical, realizable solutions for improving people's lives today. With $1 million prize, you wouldn't believe the number of issues that can be solved with a drone, at least when there's so much money up for grabs. Teams from all around the world fly in to show judges their prototypes that demonstrate how drones can improve people's lives. For example, a finalist, the Navigate, is an unmanned aerial vehicle which is designed to go where other people can't, such as confined environments in times of emergency. Its unique flying characteristics allow it to finely maneuver while stationary. It can think on its own, as internal sensors create a map of the infrastructure. And if it does end up crashing into things, then Team Flyability may have already created the solution. A collision-resistant drone that rotates on a Genius gimbal so that it can safely bounce off the walls. There are loads more possibilities for drones to provide humanitarian relief, including providing emergency shelters. Number 6. Construction. Taking inspiration from 3D printers, it's interesting to think that drones like these mini builders may be constructing our houses in the future via layering concrete. Alternative building methods are also viable though. They may become useful builders by assembling concrete bricks rather than directly laying the concrete. The Swiss Federal Institute of Technology has demonstrated this new pioneering approach to design and construction, using automated multicopters with sensors to position themselves and deploy bricks. The same university found that drones could assemble load-bearing structures such as bridges out of rope. Think about the possibilities if we scaled this idea up so that drones could carry heavier materials. It would eradicate the need for bulky scaffolding and cranes, so in the future it may be the answer. Although in my opinion it's likely that a halfway point may be found where drones assist rather than take over the process, because drones may be slower, more expensive and more dangerous than conventional means. But the idea of assigning autonomous drones monotonous tasks once performed by humans is significant. We may even find them maintaining our skyscrapers as window cleaners. Number 5. Farming and agriculture. Drones have already been utilised for precision agricultural spraying of fertilisers and pesticides in Japan since 1991. In fact, the work of 2,500 Yamaha remotely piloted helicopters is attributed to 1 in 3 bowls of rice produced in Japan. It probably isn't long until other countries follow their lead, but the agricultural implications don't stop there. In my opinion, drones will provide solutions to even greater issues such as deforestation. Since traditional hand planting cannot keep up with our industrial scale deforestation, how about making tree planting at least as efficient as tree cutting is? Biocarbon engineering is pioneering this idea. Just imagine how many trees one drone can plant on its own if it shoots small paintball-like seed pots into the ground using a device similar to a paintball gun. If this is carried out at a precise rate according to computer mapping, it's surely the most efficient way to replenish our forests. Number 4. Aerial and 3D mapping. 3D mapping combines images from many different viewpoints to make a three-dimensional model. Pix4D used it to map Christ the Redeemer in Rio and realised that it could serve as a reference in case of damage. In other applications, drones may be able to help map out vast landscapes as detailed digital models to save time creating them for video games or special effects purposes. Drones are also ideal for surveying landscapes or inspecting vast constructions. Aerial imagery for farming is also already a thing and may significantly increase crop yields. Providing bird's eye view pictures of farming fields, farmers will be able to identify specific areas with unhealthy crop conditions. For example, using an NDVI indicator, healthy plants from a crop can be distinguished from unhealthy ones, and thermal temperature maps can provide information on irrigation. It's debatable whether it's actually cost effective, though even a few percentage gain in crop yield may make it worthwhile. In the future, great multispectral imaging developments may even enable us to identify minerals deep in the ground. Number 3. Filming and photography. Of course they already perform this function, but they'll probably be just as important for this use in the future, and there are developments which are still yet to be implemented for this purpose. Drones made by DJI and Unique somewhat pioneer the market in terms of fidelity and 4K video recording, and the trend towards these goals will continue, but purposes may change. They've proven ideal for discreetly filming dangerous wildlife, and it'll be a great way to show off real estate. Perhaps combined with 3D mapping, potential house buyers will be able to tour houses online. And flying them will get easier. The Ghost drone is one innovation that looks extremely easy to control via an app. And for capturing that one perfect coherent shot, ground control software like Droid Planner will be incredibly useful in the future so that filming is automated and smooth. And we know that drones are great for capturing action sports. Innovations that can fly and follow autonomously, such as the AirDog, are likely to develop further. Something which I'm particularly looking forward to though is the Lily Throw and Go drone. It's waterproof and will potentially follow you around for 20 minutes. Imagine how cool this tech would be for vloggers in the future. Drones may even rule the selfie stick obsolete. The Zano is essentially a very simple device that can capture images with ease. Number 2, expanding internet coverage. One day the world will probably be connected thanks to drones. Imagine that no matter where you are in the world, even if you're stranded on a desert island, you may have coverage. It might seem far-fetched at the moment, but Facebook and Google certainly don't think so. They've both purchased solar-powered drone companies in 2014 in pursuit of this goal. They're specifically working on connecting isolated parts of Africa to the rest of the world. And to do this, Facebook in particular will use high-altitude flyers as part of a network of linked satellites so that drones and lasers can beam internet to remote communities from the sky. Their current prototypes are lifted to height by balloons and have a wingspan greater than a commercial plane despite weighing less than a car. Google's drones are also designed to fly high above commercial air traffic and potentially remain aloft for up to 5 years. And they're even experimenting with balloons by themselves in their Project Loon. Number 1, logistics. It's no secret that companies including Amazon, Alibaba and Google are experimenting with the possibility of autonomous drone deliveries. Not only would it save human effort, it would free up the roads and increase convenience for customers. Even though they are unable to carry much, with a current limit of £5, Amazon said that 84% of its orders fill this criteria anyway, so it is possible today. Yet some serious issues remain. Packages may be stolen and drones may be shot down or wirelessly hijacked. But these aren't the main reasons preventing us from having things delivered in hours. More generally, safety and privacy issues remain, and with current legislation in America particularly, it's just a matter of when rather than if. Nonetheless, being the quickest delivery method, drones present an exciting prospect for foodies out there. A Silicon Valley startup's plans of a drone delivery service called Tacocopter offered a glimpse of what would be possible before FAA regulations shut it down. It's not only food though. Deliveries of aid or military supplies may be fulfilled by these autonomous robots. They have the advantage of circumventing traffic to offer time saving on life or death matters such as organ delivery. They may even eventually deliver vaccines to stranded survivors in dangerous isolated areas. DARPA is even developing lightweight, cheap, expendable drones that will disintegrate once delivery is complete. There are so many possibilities that I'd be willing to bet that drone-vertising becomes a thing. In reality, drones are capable of carrying out many of these uses right now, but issues regarding legislation and drone traffic management are restrictive. The uses of drones really seem endless, and there are undoubtedly hundreds more practical uses. So what do you think drones will be doing in the future? Thanks for watching, and subscribe to be amazed.
Right, so hope that you learned something from that one. Let me just go to my second part of my talk. No, now that we
Have drones taken?
Now that we just stop sharing, I'll just share my other screen. So this one I would like to give more details about the DREAM system. Now that we saw the importance of drones in the future, how can we now be ready for drones? And what we did was we created this package, the DREAM system package, as I've discussed earlier. It comes with a hardware, a software, which is the ground station control, your modules, that are learning modules for both teachers and students, and we provide also training for it. So it's a complete package in order for you to be able to integrate it within your curriculum. So let me just give you, so these slides, the next couple of slides, will give us an idea what is the modules, what is the system all about, and how did we design it for students or faculty to be able to learn this. As I mentioned earlier, we have our hardware, our software, and our modules. These are like screenshots of our hardware, which is really a hardware configuration that you can modify. No? You can even change its configuration. You can add more sensors. You can even add a companion computer. No? So there's really a lot of modifications that you can do to the hardware. With regards to the software, it is a industry-grade software, no? Wherein you could connect directly to the hardware, be able to calibrate it, be able to understand how to control it, and be able to see where the drone is flying anywhere in the world. So this is the software that is also being used by commercial drone operators right now. And then the modules are used in order now to integrate these two hardware and software. No, it's like an integrating tool, a learning tool. No, in order for us to facilitate the learning process of understanding both the hardware and the software and their integration together. So that is how we designed it. Let me just show you an example, no, of some of the modules, no, that can be found together with the system. So the hardware, when we talk about the hardware of the drone, the heart of any robotics hardware is the controller. No? And specifically, we use a commercial flight controller in our drone, which is called Pixhawk. It is an industry-grade flight controller, and it has all the different implementations for a flight controller, not only to control actually quadcopters or rotorcrafts or fixed-wing drones. It can even control land-wheeled robots. It can also control surfaced robots. It can also control submarines. No? So it is really a multi-purpose flight controller. No? And it is, of course, the brain of the drone. It has all the different connectivities. No, of course, I will not bore you with all of them. No, but we discussed this. No, in our modules, you get to understand all the interfaces, all the LEDs. No, what is SPI, serial, telemetries. No, in order now to understand the hardware, and of course, it also comes with micro SD in order now to save the flight data. No? Of course, it has interfaces and auxiliaries. So from the hardware, example hardware, which is the flight controller, it is now connected to our software. So as I mentioned earlier, the software could control a fixed wing, could control a ground vehicle, could control any rotorcraft. No? And when I say any rotorcraft, it could be quadcopter, tricopter, octocopter, hexacopter, and there's even a hybrid mode, no? A hybrid mode which combines now fixed wing and rotorcraft all in one, no? Combining both the best of both worlds, and of course helicopter mode. No? So these are so from the hardware, it shows you how to connect to the software and to the correct frame that you are that you would like to use. No? And then you will now see an interface where you would like to fly it. No? So this is actually the football field of De La Salle, no? In Laguna campus. So from the mission planner, from the ground station, from the software, it's now connected to our hardware. Then from the connection, it will now show all the indications on how to connect it and how to configure it. How to configure the controller for the software. So a step-by-step procedure can be seen in the modules, no, so that you can understand them better. At the same time, there are a lot of screenshots and images that shows us how the flight controller, how the positioning of the drone itself. Of course, when we talk about flying, we're talking about roll, pitch, yaw. No? So when we talk about roll, it is moving along the roll axis, no, or usually the x-axis. We call it as the x-axis, and then we have the yaw along the z-axis, and then we now have the pitch, no, which is along the y-axis. So depending on your when you connect it to the software, you would now already see the hardware moving, no, in the software itself, no? So this is the pitch moving in this direction and the yaw. So we have also presentation materials that already gives you a video of how to connect them. Like in this particular case, we now have our controller being connected now to our software. And while it is connecting, and when you do all the setup, we now have this HUD. No? This is called the HUD, no? The heads-up display, which tells us what's happening to the drone. Is it turning left? Is it pitching left, pitching right? Is it also, this one is the pitch. This is the roll, sorry, no? When it is rolling. So you could also see the HUD moving. Then this one is the pitch, no? When it's moving in this direction. Again, you would see it in the HUD, and there will be displays and data acquired. And then this one is the yaw position, no? When the flight controller is installed into the drone itself. So it has this presentation menu, and you can acquire those data and see visually what is happening. So in the hardware side, there's also a step-by-step understanding on how to assemble a drone. No, of course you can create your own drone later on. No, so this just gives you an idea on how to assemble a particular drone. But you can. The beauty is that you can create your own drone later on. No, in fact, in the university we have created several modifications of the drone itself. No, so it shows you how to connect each step, no, understanding which are the screws in this case. No, you can create a 3D printed design of your drone if you like. No, then it also shows you how to mount each of the motors. So it's really a step-by-step guide on how to build a drone. But of course, you will be creating your own drone, or you can now use your learnings in order now to create your own drone in the future. Then again, we now have some presentation materials which lets you visualize now how the assembly process is done for each component. And in this case, it tells you how to build the frame, how to assemble the different components, how to put in all the different components from the arms to the legs of the drone, using a CAD software. So this one is, so you can even use a CAD software to create your own design, and then create your own motor design, and motor implementation. So it really, the modules and the presentation material gives you an understanding, even doing this on. In fact, we did this online, and we were able to successfully deliver the technology, to even if in an online situation, from all the different components like telemetry to the power to the flight controller. So all of these components were assembled and transferred in terms of knowledge to the different participants. So this is one way of which we could push through with online learning, which is what we're doing right now. We're looking at different ways, different possibilities of producing online learning to our students, so that they will not be left behind. All right. So you may even use this CAD design in order now to analyze it. If you have your softwares, if you have your FEA or CFD softwares. So this is the assembled drone that we have. It is complete with all the sensors, from GPS. You have your IMU or inertial management system. You have your barometer, so on and so forth. The different sensors will be discussed also, and it also discusses in the modules the different calibrations, that is to be done. Again, step by step, from the software to the hardware. What you need to do with the hardware. Again, we now have videos on how to do the compass calibration, which tells us what is the direction of the drone, when it is flying, especially when it's flying, when it moves in different directions. Sometimes you don't know where it is, then the compass automatically gives you all of those data. So as you can see here, the drone is constantly in communication with the software, being able to calibrate each of the sensors, step by step, in this case, the compass calibration, but we do radio calibration also, accelerometer calibration, so on and so forth. So there are a lot of just learning the sensors itself, it's already quite an advantage for the student, in learning these things. Then, of course, flying. So there's also a step-by-step instruction on how to fly the drone, safely flying it in outdoors using the GPS, So step-by-step, how to calibrate it and how to fly it in loiter mode, which is the first safest mode of flying the drone, because it is in a certain position. It is only targeted at a certain position. As you go along, then you can build your skills on flying the drone. Then finally, I would like to just give you some sample comments on some of our deployments. Now, in this case, we were able to deploy it to one of our participants was with UST, and from UP Baguio. And let me just give you some of their. Sorry, I will again stop sharing because I don't think I was able to. I was able to share the sound. So let's listen to a short comment after we gave an online training. This one is an online training because of the limitations of the pandemic, So we did an online training to them for our dream system, and these are some of their comments and reactions after the initial training.
So yung sa akin naman, yung
I'm sorry.
natutunan ko dito.
Let me just go back to
implemented is actually very exciting because our institute within the university, the Institute of Information Computing Sciences, we were given a brand new building.
Let me just, sorry about that. Let me just increase the, parang medyo mahina yung sound. Sorry about that. If I can just, let me just verify my sound. Oops. I'll stop share again. I'll share it again. Sorry about that changes. Because I'll just check if I shared it. Yeah. I hope this is good. Let me just go to that.
Implemented is actually very exciting because our institute within the university, the Institute of Information Computing Sciences, we were given a brand new building and a brand new laboratory for this. And one of the things that we wanted was to come up with some sort of research laboratory for IT automation. And this drone was actually the perfect opportunity. And we were very lucky and very appreciative with XLIPAD team that we were considered for this project. So we're looking forward to it, having our students interact with it. I'm hoping the simulation software, siguro probably by tomorrow, we'll get to learn and have our students also experience that. Even though right now, naka-online lahat, at least by seeing how the simulation software will work, maybe we can have it by next semester introduced to our students as well, so that when we do have the face-to-face, pag nakita na nila yung actual drone, we can, they'll be excited na, ito pala yung nagamit namin nung nag-online pa kami. So that's about it.
So here's another one. So it's just another perspective in terms of yes.
So yung sa akin naman, yung I think natutunan ko dito happens, I think it's a very complex system, no? And also I appreciate that you discussed the different parts of it in detail. And I also got interested yung sa table na pinakita niyo yung may green and red. Well, you discussed how the propellers move, no? When you increase the speed of certain propellers para it will move in certain directions. I'm interested in the kinematics, no? Kasi, by the way, I'm a faculty from UP Baguio, and I'm glad there's Ma'am Roxanne here from also from the Cordillera, no? Yun nga, ang aking interest, hello po. Yeah. Ang interest ko kasi is more on kinematics. I'm teaching a graduate class dito sa UP Baguio on the applications of algebraic geometry on robot kinematics. So I was thinking on how we can use that kasi we are thinking of having a robotic simulation lab, pero maganda na may actual din na robot, no? Rather than just simulate. But I'm thinking of introducing this to our graduate students, and also if look at the movement, the kinematics of it, and also if tanong ko rin if you have some open problems, open research areas for research, no, that you can suggest for this product. We'll be happy to work on it, no, with kasi also meron din akong research group, no, na nililid. So maybe we can discuss, we can talk about it. So, yun lang po.
That's right. Then finally,
first, I do agree and I do share the learnings from what Mia has said. Then another takeaway that I can share is that I was really amazed with the process of how the drones can be autopiloted or can be run into autonomous mode by using the certain applications such as the mission planner, because that is the one very thing that I'm very curious about. I do have a simple drone, a simple unit, but it's just for for flying such, and yung parang laruan lang po, and a simple camera for documentation purposes. And I do look forward for the other further opportunities that I could explore also comes to the drone. Targeting the mandates of the institution, not only instruction but also the research and extension. Because in our institution we have, I think, 2 drone kits here, but they are primarily being used for documentation purposes only. And we are the planning division is the one who owns that drone. So I'm very much excited to look forward so that the drone can be turned over into the Office of the Vice President for Research and Extension so that we will be able to explore further possibilities. And my immediate supervisor also extended her support to the drone to this drone technology. So it's very exciting here in our small province in Camarines Norte. First, I do agree and I do share that.
right. So finally, we are XLIPAD is offering a special offer, no, of the Dream system, no. Right now, since government would really want to move forward with drone technology to be part of universities and colleges, no, all around the country. The hardware is we have limited hardware that we can donate, no, to universities, no, through DOST and De La Salle University, no. So this is a limited offer. However, there is of course, for the software, the installation, the modules, no, that we've created, the learning materials, no, the training of faculty or students, no, there is a certain amount of cost for that one. No? So if you are interested, please to have this special offer to be part of your university, especially, of course, because of PAES. We would like to invite you to email me, no? Email us at xlipadsolutions8@gmail.com, or you can email me directly also, no? At alvin.chu@dlsu.edu.ph. No? So we hope that I hope that we were able to XLIPAD was able to impart some information and some technology about the importance of drones in the Philippines, no, and all around the world. And we hope that you will be with us in this journey of improving the quality of education in the Philippines, at the same time giving our students and our future leaders, no, the skill and capability that they need, no, to be future leaders, no, in their own right. Maraming salamat po.
Thank you very much for that, Dr. Alvin. So I do hope that the audience was able to take something away from that particular lecture. So now we're in the Q&A session. So I invite anyone who has a question for Dr. Chua to kindly type it in the chat box. So you can see the chat box at the bottom of your screen or the panel of your Zoom. So maybe we'll start off with this question. Maybe we need to repeat if it hasn't been if it has been discussed already. So typically, how much will one unit of the drone educational kit cost?
Okay. So as I mentioned earlier, no, it's a package already, no. So if we're talking about the Dream package, no, we usually look at it as a classroom, no. So like 5 drones, no, that a student can or a group can work on together with the software and the modules, no, which are available, and also with regards to the training, no. So with regards to the actual quotation, they could actually email us, no, for specific details, no, so that we can talk to them, and also that we can also customize, no, in terms of the need of the university, no, kasi sometimes like some of the universities that we were able to talk to, they would like to implement it as part of their research, no, so because it is a platform for research, also for innovation, so we could customize the pricing, we could customize the packages, no, depending on the need of the university, no. Some even applies it to their elective classes, no. So they implement some parts of the drone system or of the Dream system in parts of their curriculum, no. As mentioned earlier, no, paminsan pwede siya sa physics, pwede rin siya sa aerodynamics class, no. Or you can of course use it in electronics classes, no, or even in software classes, no, if you're doing some bit of programming and simulations.
Okay, for the trainings, like how long are the trainings typically?
Okay. So again, it depends, no. But for the Dream system package itself, we were able to have a 2-day training, no, in order now to complete the whole 10 modules. There are actually 10 modules in the Dream package, and all of them will be touched in this 2-day training. Although we also customize trainings, no. We have some universities that are interested in some online trainings, no, or even face-to-face trainings, no. So we could customize whether it be 1 day, no, or half a day, no, depending on the need, no, the need of either students or faculty for that product or for that concept.
Yeah. So at the moment, so you mentioned that there are modules and activities, I suppose, that already can be done in the class. So is this sufficient for one course, for example, or half a course, or how do you see it?
Actually, we designed it like one module is around 3 hours of laboratory time. So if we're going to look at that, it is actually it can already handle a complete course, no. But we understand that sometimes a university might not have a separate course, no, especially for drone. So they could actually customize it, no. We can even help them in terms of customizing certain modules to be part of these courses, no, if it doesn't fit a particular single course itself. But the answer is a yes, it could be already a whole course, but can still be broken down to different modules, or they're modularized so that you could insert them into different courses or different modes, no, where you see fit in your class.
Okay, thank you for that. So we have another question. Do you have any prototype already for fixed wing drone?
Actually, we in fact in our DOST project we also have fixed wing drones, and that is our platform, no? But as of the moment, we are not selling those platforms. But if you are interested in fixed wing drones, we could actually talk, and we have actually a lot of available fixed wing drones, and that we can collaborate with, no, and see, no, how we can go, how can we move forward. As of the moment, we are concentrating on the quadcopter, in terms of the modules itself, no, in terms of the first implementation.
Okay, I have another question. You know, if they take the educational kit, do they need any additional platforms or any additional systems to be in place in their institutions before they can actually make use of it? Because I heard you mentioned a while ago that you can actually use CAD to design, but what if we don't have CAD, for example, in a university? So are there any additional requirements so that they can make use of the educational kit?
Right. Actually, with regards to the Dream system itself, basically none, no? As long as you have your PC that can download the software and can run the software, no, Windows PC, no? So basically that's it, no? When I was talking about CAD, usually we have some CAD softwares in the university, but if none, it's all actually okay. There are actually also some free CAD softwares that you can also use, no, in order to design your drones, no, as one of the activities, no, that you may have, no, in developing your own innovative drones.
Okay, there's a question here from Harold. So you also already mentioned a while ago that this particular technology is not really new. I mean, there are already others existing out there. So he's asking, so it seems like all the hardware and the software are all open source. So how do you actually differentiate this Dream system from what is already available out there? What is the value proposition of XLipad, for example?
Wow, it's basically one is the learning modules, no, so that we have designed, no, specifically coordinating this hardware, no, this drone hardware together with the software, no. So that is not yet been done, and that is part of the process, no, that we went through as of course coming from our experience as professors also in the university, and at the same time as researchers, no, because of the knowledge that we've gained from going to different countries also who are doing drone education or drone technology. So with regards to the hardware, another value proposition there is that it is an open platform, no? So meaning with that platform you can actually add sensors, you can add also payloads, you can add also a companion computer even, no, that can connect to the controller, no, the Pixel controller that I mentioned earlier, and create more innovations, no. You can even add a machine learning algorithm, no. Like in one of our projects, we implemented a hardware that can do video processing, no, and we connected it to the flight controller. Whereas the video processing can be handled by that companion computer, while the flight dynamics can be handled by the controller itself. So it's really an open platform. So it's really kumbaga, you are able now to change the hardware, even to changing the copter itself, no? If you want to change to another copter and just use the controller, you may also do so, no? Kunwari, you plan to use a land vehicle, or you plan to use a surface vehicle. So we have those projects also, no? So you can also use that. So that's part of the value proposition. It's innovativeness in terms of platform, and at the same time, the value is that you'll also be learning a industry grade software, no? So the software can already do a lot of simulations already, no, which is very important for us, no, in terms of developing programs, developing tasks, or developing implementations that can make use of the drones, no, just in simulations mode. So there are a lot, no, there are a lot. So if you want to go into Python programming, no, if you want to really go technical, no, you could actually use the hardware as a tool, no, in order now to implement your Python programming also.
Okay, thank you for that, Dr. Shure. So I'll just take the last question from Daniel. So is it okay? So he actually has two questions. Is it okay to use Betaflight Configurator in teaching our students? What's your feedback?
Sorry, I wasn't able to get that.
Beta flight configurator.
I'm not sure what he's maybe that's a software, no. But in our case, we use a commercial grade software, no, that is being used really by commercial drone flyers, no, here and abroad, no. And it is, the beauty is that you could actually even change it or modify it, no, if you have the programming capability, no, to add on artificial intelligence to it. You may even modify it to that extent.
Okay, he actually has a follow-up. So is it okay? If it's too advanced, they also use F4FC stack as part of their laboratory. Would you be familiar with the F4FC stack? And can you comment on that?
Not really. So,
Okay.
so not really sure about that particular software implementation.
So thank you.
Because like in our case, no, maybe he's talking about the details, no, of the flight stack, no. Because when you talk about the flight controller, there are actually different levels of it. We actually also discussed that, no, as part of the modules, no. Just understanding the software itself, no. There are different levels, no. There's the control module, the sensor module. You have the flight modules, no. In fact, when we were studying that one, when we studied that as part of our research, it took us probably a year or two, no, in order to just understand the interconnectivity of things, no. So different, as far as my understanding goes, no, there are different ways of implementing the software, no, and just understanding how to do the motor mixing, no, yung binabanggit kanina during the deployment, no. Creating a motor mixing is already a challenge, no, in terms of the different levels of programming for that one, no. So maybe he's referring to some of the levels of programming in the software, and that is also part of the software discussions.
Okay, thank you very much for that, Dr. Chua. So I just have one last question. Does XLIPAD also provide like customer service? Like for example, after they've acquired the educational kit, can they always come to XLIPAD if they have any additional questions or if something breaks down in the system or anything like that?
Oh yes. So we have a customer maintenance period, no, after the delivery, and of course we would like to support this after the delivery and make sure that you're able to use the product well.
Okay, thank you very much for that, Dr. Chua. So I know that this topic is really, really interesting. So if you want to know more and if you want to get involved more into the drone, so please don't forget to contact Dr. Alvin Chua at alvin.chua at dlsu.edu.ph or the email address of XLIPAD. I'm sorry, I didn't quite get that. So I'm sorry, that's all the time we have now. But before we end, I'd like to call Dr. Romano Neira, Second Vice President of PAES, to present the Certificate of Appreciation to our speaker. Okay, so let me just share my screen as well for the Dr. Neira. Dr. Neira, are you there? You may now unmute.
Yeah, hello.
Okay, thank you.
Hello, good morning. Do you hear me, Dr. K?
Yes, we can hear you.
Yeah, good morning. So I have the honor to present the Certificate of Appreciation to our speaker. So this Certificate of Appreciation is hereby presented to Dr. Alvin Chua for his invaluable contribution as a speaker during the PAES webinar entitled Drones Are Coming, Are You Ready? Given this 25th of May 2022, signed Dr. Kathleen D. Abiso, Director for NCR, and the event head for this particular seminar, and Dr. Filipina de Guzman, the Secretary of PAES and also the event head, and also our PAES President, Engineer Evelyn Curagindi. Dr. Alvin Chua, thank you very much.
So thank you very much. Maybe we can do a photo op with Dr. Chua. Hold on. May I request? May I request John Ray Estrellado to kindly take the photo of Dr. Chua, Dr. Nera, Dr. Ragindian, and Dr. Evelyn. Spotlight. Add spotlight. JR, can you please direct us and let us know once you're done with the photo? JR, are you there? Yeah, we can't seem to hear you. Okay, so anyway, okay, 1, 2, 3, smile everyone. JR, perhaps you can write in the chat if you've already completed the photo.
Having technical difficulties.
Okay. Sige. So just let us know. JR, okay na ba? Okay, so just a few more seconds. Okay, smile again. Hold on, let me just hover. Okay, so please smile. 1, 2, 3, smile. Okay, so I hope, okay, sorry, JR is having technical difficulties. Okay, but I think I got the photos. Okay, thank you so much again, Dr. Chua and Dr. Nair. Now let's proceed to our closing remarks. I would like to call Engineer Nilo Arago, Board of Director for NCR, to give us the closing remarks.
Okay, thank you very much, Dean Kay. Can you hear me?
Yes, we can hear you.
Okay, so good morning. So truly, it's a very great day today that we know all of this with regards to XLIPAD. First, I just want to give some of my takeaways. Okay, so first is that XLIPAD is a dream not only because of its acronym DREAM, Drones Reimagined for Education, Application, and Modification, but it is a dream that came to reality. It is a spin-off company that will lead into a new ways of learning, communicating, and collaborating as their vision. So as our speaker said, robotics is fun. It can develop students with regards to their education, and it is inexpensive also. But XLIPAD introduced a budget technology. Okay, so XLIPAD started as a research project back in May 2017 under the Center for Engineering and Sustainable Development Research of De La Salle University's Gokong Wei College of Engineering. So XLIPAD team has come a long way in realizing their vision from developing a free dream kits to gaining significant demand from universities around the Philippines. XLIPAD Dream system is a complete and flexible drone educational system that can easily integrated in schools curriculum to explore multiple areas of technology using the UAV technology. So the system features a unique assembly and autonomous build that were developed under the learn and play concept, which opens up an exciting platform for students to learn the principles of programming and engineering. Through this technology, our student can be interested in a lot of applications in drone in terms of military, research, industrial, agriculture, specifically in smart agriculture, smart farming, even in photography and videography, entertainment, delivery, weather forecasting, disaster management, etc. So XLIPAD gives a whole package composed of hardware, software, modules, and even training for faculty and students. Okay, completo. So purchase na tayo. Okay, so I just want to give a thank message to our speaker, Dr. Alvin Chua, the president, the chairman of the board of XLIPAD, for sharing your company with us. Thank you very much. Thank you in behalf of PAES. Third, so I just want to promote the next PAES webinar this coming June. Okay, let me share the format of this webinar. Okay, so the topic is about incorporating design constraints into capstone projects for plant design courses. So it's all about what these design constraints are, how design constraint can be addressed and incorporated into capstone projects for plant design courses, how capstone design projects can be implemented to meet the PTC, the CHED, and ABET accreditation requirements. So our speaker for this webinar is Engineer Roda Leron, an associate professor of Mapua University. So again, this webinar will be on June 27, 2022, 2 o'clock to 5 o'clock via Zoom. So for a while. And also, so sa ngayon, so we have for the active members, for the members of PAES, so free po yung dalawa. Okay? And if ever na it's more than 2, so meron po tayong fee for 200 pesos. And for non-members, so 300 po each. So for your registration, I'll be posting on the chat box for the link of the of the registration. Kindly please, so signify your interest on this webinar. Thank you very much, and I hope that everyone ay natuto on this webinar, and we are inviting you on June 27 again. Thank you very much, Dean Kay.
Thank you very much for that, Engineer Arago. May I request everyone to open their camera so we can take a group photo. So we currently have 6 panels. So please hold. So kindly keep your cameras on because we're not sure which panel you are in. All right. Okay. Okay, Din Eve, are you there? Would you like to turn on your camera? Okay, so please smile, everyone. Smile. 1, 2, 3, smile. Okay, that's panel 1. Please hold. Let me just. Okay, next panel. Please smile. Okay, 1. Okay, please turn on your cameras. Okay, 1, 2, 3, smile. Okay, please hold. Okay, let me check my next panel. Okay, it seems that nobody has turned on their cameras in the next channel, in the next panel. So I guess that's it. So let me just share my screen. So I've also posted the link for our evaluation. So we'd greatly appreciate it if you'd let us know how we did with this particular webinar. Please answer our evaluation at bit.ly/eval_paesxlipad, or you can scan the QR code and it will take you right to where the evaluation portal is. So with that, thank you so much for joining us this morning, and we hope to see you next month for the next webinar of PAES. Thank you once again.
Yeah, once again, thank you very much to all participants, professors, researchers, and students from higher educational institutions, both government and non-government organization representatives, and to everyone, PAES board, thank you, and to the LSU, thank you very much, Dean Kay and your staff. Thank you to everyone. See you on June 27. God bless po.
Thank you, Dean Lien. Thank you, everyone. Have a good day ahead.
Thank you, Dean Kay. Thank you, Dean